Welcome students to our new YouTube channel Pharma the division of excellence. So let's start to the new chapter of modern pharmaceutics, which is aerosol. So let's start to this topic aerosol. So these aerosols are the gaseous dosage forms, and these aerosols are used in the asthmatic patients. The doctor gives the small spray bottle of to the asthma patients for inhalation purpose and to cure from the asthma. And also you see the ad of Virat Kohli Vicks inhaler. So these inhalers are also the gaseous forms. You take nasal, you take these inhalers or aerosols inhalers by nasal route of administration, and the aerosols also for your mouth. Some aerosols are by mouth or some are nose. So these aerosols, so you know that this is COVID pandemic. So in this COVID pandemic there is also the new vaccine is formed, which is directly given by the nose. This vaccine is coming soon. So next we see these aerosols. So these aerosols are the suspensions of small solid particles or the droplets of suspended in a gas or vapor phases. And the common perceptions of these aerosols are they are products that depend on the pressure of compress or the liquefied gas to expel the contents from a container. Next we see the advantages of the aerosol. The advantages like the dose can be removed without the contamination, and also the stability enhancement for the oxygen or moisture sensitivity drugs. And the next advantage is in sterility maintained up to the administration. The next we see the disadvantages of aerosols. These aerosols are very costly. So this is important advantage of important disadvantages of aerosols. This is very costly, and also aerosols pack must be stored in a cool place, and the propellant may cause the toxic reactions. So this propellant causes toxic reaction is very dangerous. And also the disadvantages like in the refrigerant, the effect of propellant may cause the discomfort. So when you take the propellant and you store in the refrigerator, the effects of propellant, due to this it may cause the discomfort of your health. So in the aerosol we see the advantages like doses can be removed without the contamination, and also the stability enhancement for oxygen or moisture sensitivity drugs, and the sterility maintained up to the administration. These are the advantages, and disadvantages are these aerosols are costly, and aerosols pack must be stored in a cool place. So these aerosols must place in a refrigerator in a cool place, and the propellant may cause the toxic reactions to your health. These are the disadvantage. And last, the refrigerant effect of propellant may cause the discomfort of your health. These are the disadvantages. Then next we see the main important part, which is components of aerosol. The components of aerosols. The first component of aerosol is container. The container is the materials. Should in the container, the material should withstand pressure as high as 140 to 180 psig. Psig is the unit of the container at 130 degrees Celsius. So in the container, the material should withstand pressure as high as 140 to 180 psig at 130 degrees Celsius. And the containers may be as metal containers. They are tin plated, steel, aluminium, and they should not be used with pure ethanol or water as they can cause the corrosion. Then next one is metal is stainless steel. So the containers made up of tin plated steel, aluminium, and stainless steels. The next one is glass container. The glass container are uncoated glasses and plastic coated glasses. So the next part is valves. So these valves are responsible for the delivery of the product in the desired form. But there are two types of these valves. They are continuous spray valve. These continuous spray valves are used with the topical aerosols, that means for your skins. And second one is metering valves. So these metering valves should accurately deliver a measured amount of the product. So this is meter valve. So the meter is connected with the aerosol spray, and you select the dose meter measurement. If you want to get 10 ml dose, then you set the 10 ml, then approximate, then 10 ml dose will be delivered to you. This is metering valve's function, that this is accurately dose is given by these metering valves. So, and the amount delivered should be reproducible, and not only for the dose delivered from the same container but from different containers of the batch as well as. Okay. So, and next we see the metering valve components. So in the metering valve components, they are ferrule or mounting cup. So these ferrule or mounting cup, they are used to attach valves properly and properly to the container. So this ferrule or mounting cap is used to attach valve properly to the container, and they are made up of tin plated steel, although aluminium can be used in mounting cup. And next material is wall body or housing. So this wall body or housing is made up of nylon or delrin. And next material is stem. The stem is made up of nylon or delrin. And next one is gasket. This gasket apparatus, not gasket apparatus, this is material of wall component is gasket. This gasket is Bunayan and neoprene rubber. So in the GPAT there is a question, the gasket is, what is gasket? And the right answer is Bunayan, and this gasket is neoprene rubber. And also the next material is spring. The spring is loaded. The spring made up of stainless steel. So the next material is dip tube. So this dip tube is from polyethylene or polypropylene. So the third main component part of aerosol is actuator. So this actuator is to ensure that the product is delivered in the proper and desired form. A specially designed button or actuator is fitted to the valve system. So this actuator is for the delivering of proper dose and desired dose, and this is a specially designed button. This is actuator is fitted to the valve system. They are in the spray actuator, foam actuator. So they are spray actuator, foam actuator, solid stream actuators and special actuators. So and it also allows for easy opening and closing of the valve and is an integral part of almost every aerosol package. So this actuator, it allows for easy opening and closing of the valve, and it is an integral part of almost every aerosol package. So this actuator is the most important in components. So all the parts are very important for components, for aerosols components. So the next one is propellants. So the propellant is responsible for developing the proper pressure within the container, and this propellant, it expels the product when the valve is opened, and it aids in the atomization or the foam production of the product. And there are mainly two types of propellant they are used in the aerosol. They are hydrocarbon gases. They are propane, butane and isobutane, and compressed gas. The compressed gas are nitrogen, carbon dioxide and nitrous oxide. These are compressed gases. Then next we see the fluorinated hydrocarbons. So in the fluorinated hydrocarbons, propellant 12, this propellant 12 is known as difluoromethane. So next one is propellant 11. The propellant 11 is a trichloromonofluoromethane, and propellant 114. This propellant 114 is known as dichlorotetrafluoroethane. Next we see the laws for the aerosol. This aerosol works on the Dalton's law, in that the total pressure in any system is equal to the sum of the individual or partial pressure of various components. That means P total vapor pressure is equal to PA plus PB. That means it is the sum of total vapor pressure in the system. And also when PA plus PB are partial vapor pressure of component and A and B respectively. So next law is Raoult's law. This Raoult's law is the lowering in vapor pressure of liquid by the addition of another substance, and it states that the depression of vapor pressure of a solvent upon the addition of solute in proportional to the mole fraction of the solute molecules in the solution. That means Pa is equal to Na upon A plus Nb into vapor pressure of pure propellant P not A. The PSIA, this PSIA means the pound per inch square absolute minus 14.7 PSIG pound per inch square gauge. Then next we see the types of inhalational devices. So the first type of, so there are three types of inhalational devices. In that, first type is meter dose inhalers, then next nebulizers and dry powder inhalers. So let's see, the first one is meter dose inhalers. So these meter dose inhalers are mostly used to deliver the suspension aerosols, and the principle of operation is, in meter dose inhalers is a material chamber fills with the suspension as can is inverted, and by depressing the valve stem the metering chamber is simultaneously closed to reservoir and open to atmosphere by the actuator jet. And as the atmospheric pressure is much lower than the equilibrium, the vapor pressure is the can, and the propellant vaporizes rapidly, and which propels the suspended particles through jet to the patients. So these are the functions of meter dose inhalers, and this most widely used in the delivering of suspension aerosols. Then next we see the nebulizers. There are two types of these nebulizers. They are jet nebulizer and ultrasonic nebulizers. So first we see the jet nebulizers. So the jet nebulizer's principle of operation is by passing air at high speed over the end of capillary tube, and liquid may be drawn up to the tube from reservoir in which it is immersed in Venturi or Bernoulli's effects. So this Venturi or Bernoulli's effect we see in the physics in 11 or 12th standard. This is the principle of jet nebulizer, is Venturi or Bernoulli's effect. Then this jet nebulizer is when liquid reaches end of capillary, then it is drawn into the air stream and forms the droplets that disperse to become an aerosol. And next one is ultrasonic nebulizers. So the principle of ultrasonic nebulizers is, it is based on the principle of operation is that it uses piezoelectric transducer to induce waves in a reservoir of solution, and interference of these waves at reservoir surfaces leads to the production of droplets in the atmosphere and above the reservoir system. And also an air stream is passed through this, so that this an air stream is passed through this atmosphere to transport the droplets as an aerosol. So this air stream is passed through this atmosphere to transport the droplets as an aerosol. This is most important in ultrasonic nebulizers. So next we see the dry powder inhalers. So the dry powder inhalers are based on the principle of operation of dry powder inhalers is the capsule is placed in spinhaler devices, and it pierces the capsule by a special mechanism, and this spinhaler this pinhealer rotates the capsule under influence of patient's breath and ejecting aerosols particles into the airstream, and these particles pass through the rotor blades and they are collected or deaggregated to ensure that small particles is administered to the patients. So next we see the propellant filling method. There are two methods of propellant filling methods. They are cold filling. In the cold filling, the product's concentration is cooled to 0 to 10 degree Fahrenheit and then added to the containers. And in cold filling, the propellant is refrigerated at minus 20 degree to minus 40 degree Fahrenheit and added to the container is cold liquid. And this in cold filling, the moisture elimination is problematic. So next method is pressure filling. So this is pressure filling is the first product is concentrated product is first is added. So in the pressure filling, first concentrated product is added, then through the valve opening propellant is added by pre-assuring the propellant at temperature of filtering. So in the pressure filling, through the valve opening propellant is added by pre-assuring the propellant at temperature of filling area headspace air may be compressed and therefore the headspace purging is necessary. So next propellant filling method is leak testing and burst testing. So in the leak testing and burst testing is done by passing filled and sealed aerosols products container through the hot water tank for 3 minutes. This 3 minutes is accepted time, and these containers should be heated at about 55 degrees Celsius, that means 130 degree Fahrenheit, and observe for leakage or bursting. So and also the temperature should not rise more than 60 degrees Celsius. And also in leak testing and burst testing, the leakage is detected by visual inspection of the fine bubbles. So and also the finished product specification are flammability and combustibility. So the first one is flash point. This is measured by use of the standard tag open cup apparatus, and the aerosol products is chilled to a temperature of about minus 25 degree Fahrenheit and they transferred to the test apparatus, and this test liquid is allowed to increase slowly in the temperature, and then this temperature at which the vapor ignite is taken as the flash point. The next one is flame projection. So this test indicates the effect of an aerosol formulations on the extension of an open flame, and in the products is sprayed for about 4 seconds into a flame, and depending on the nature of the formulation, the flame is extended the exact length of measured with a ruler. So next we see the physiochemical characteristics of these aerosols. They are vapor pressure. This vapor pressure can be measured simply with a pressure gauge. The next physiochemical characteristic is density. The density of an aerosol system may be accurately determined through the use of hydrometer or a pycnometer. So the density of an aerosol system may be accurately determined through the use of hydrometer or a pycnometer. So in the GPAT there is a question, the density of aerosol can be determined by which instrument, and the right answer is hydrometer or a pycnometer. So majorly pycnometer is the option in the GPAT. So next is moisture content. The Carl Fisher method has been accepted to great extent of gas chromatography may be used, and this gas chromatography may be used for this purpose. So in moisture content, the Carl Fisher titration and gas chromatography are used. So next is identification of propellants. So in the identification of propellants, gas chromatography and infrared spectrophotometry have been used to identify the propellant and also indicates then proportion of each component in a blend. And the concentration propellant ratio is the performance in the concentration propellant ratio. We see the performance of aerosol or valve discharge rate. This aerosol valve discharge rate, this is determined by taking an aerosol product of known weight and discharging the content for a given period of time using standard apparatus, and by reviewing the container after the time limits has been expired, and the change in weight per time dispensed in the discharge rate, which can then be expressed as a gram per second. So next is spray pattern. So the spray pattern testing also is based on the impingement spray on a piece of paper that has been treated with a dye talc mixture, and depending on the nature of aerosol, an oil soluble or water soluble dye is used. So the next one is a dosage with meter valves. In the net content, the net content is the tarred cans that have been placed onto the filling line and reviewed, and the difference in weights is equal to the net contents. Then next is foam stability. This foam stability is the life of foam can range from a few seconds, that means for some tweaking or in breaking forms, to 1 hour or more on depending on the formulations. So next one is particle size distribution. In the particle size distribution, the cascade impactor and light scatter decay methods have been used for the determination of particle size distribution. So in the GPAT, there is a question, which methods are used for the determination of particle size distribution, and the right answer is cascade impaction and light scatter decay method. And also the aerosol dynamic particle size is more appropriate for the inhalation of aerosol. So this aerosol dynamic particle size, that means APS, is more appropriate and most important for the inhalation of aerosol and in aerosol properties. So the last one is leakage. So in the leakage, the biological testing and the therapeutic activities are in the leakage, and the toxicity in the toxicity testing should include the both topical and inhalational effects, and aerosols applied topically may be irritating to the affected area and or may cause the chilling effects. So when the toxicity testing should include the both topical and inhalational effects, aerosols applied topically may be irritating to the affected area and may cause the chilling effects. So this toxicity is when you use the inhalational as a topical agents, the topical effects may be these causes the chilling effects. This is the toxicity of aerosol when leakage of aerosol is happen. So in this way we end of this part 1 of the aerosol. So in the part 2 we see the evaluation and also some basic points and important points of aerosols in the part 2. So please stay tuned with PharmaXtech, and hope you like this video. Please, if you like this video aerosols part 1, please comment on comment section, and please share this video to more and more to your GPAT aspirants as well as CET aspirants too. And thanks for watching this video. Thank you for watching this video. Stay connected with PharmaXtech. Stay tuned with PharmaXtech. Thank you. Welcome students to our new YouTube channel PharmaXtech, the division of excellence. So let's start to